Hey, hi everyone. Welcome to Mastering Protocol series. So today we will talk about AXI write of length 2 bytes. And the scenario that we are going to cover today is we will do 4 writes of length 2 bytes to first 4 locations of our AXI slave address range hex 1002 to 1FF, which is a 4 KB. And here, what we will look at is we are interested in understanding the effects of the write crossing the data bus width boundary. And next, we will look at issuing 4 writes of length 2 bytes to last 4 locations of this address range, and we will look at the effects of write crossing the 4 KB boundary. All right, so we will look at that. So I just before we sort of go further, I wanted to give some background. So you might have read this line of the specification that a burst must not cross a 4 KB address boundary. Then how does it behave in real life scenarios? We will take a look at it. And the second one, you might have read in the transaction ordering that the data transfer for a sequence of write transactions with the same AWID must complete in order, right? So these two sentences you might have read in the specification, and if you had wondered how exactly does that get used, today we will get to have a look at it. So let's look at one more concept and then we will jump into the analysis. So we have been using a data bus width of 4 bytes, which is very frequently used in the industry. So what I have done is I have drawn these 4 bytes. Now, if the address is D-word aligned and we are using a length of 2 bytes, what it will do is it will occupy the lower 2 byte lanes. And if the address is D-word plus 1, then length is 2 bytes, then it will occupy the byte lanes 1 and 2. And if it is DW plus 2 and we are using a length of 2 bytes, then it's going to occupy the byte lanes 2 and 3, which I think is sort of is simple to understand. We can manage this using the write strobes. But the interesting case would be when the address is dword plus 3, right? And the length is 2 bytes. Now it is crossing now our data bus width boundary. So we can write 1 byte to the on the data byte lane 3, but what happens to the next byte? And what happens to the next byte if it is address happens to be dword plus 3 and it's also crossing the 4 KB, right? So let's look at these two concepts. So I have already loaded a test which is creating this scenario in this curiosity transaction visualization and analysis tool. So what I have done is in the AXI transaction, I have filtered for transaction length of 2. I am looking at completed, and these are the transaction count that are of the length 2 bytes, right? So transaction count from 9 to 16, right? So now, and we can see that the address over here is this one is dword aligned, dword plus 1, dword plus 2, and dword plus 3. Let me zoom in a little bit so that it's easy to read. So this is dword plus 3, and then we have the similar 4 accesses being issued towards the end of address range. Similarly, dword aligned plus 1, plus 2, and plus 3, and this happens to also cross the 4 KB boundary, right? So now let's look at when this happens, how does the AXI bus behaves? So today what we will do is we will look at first 4 transactions which will lead to data bus width boundary crossing, and the last 4 transaction which leads to data bus width crossing coupled with the 4 KB, right? So how do they behave? And then we will contrast it a little bit. So the idea of looking at multiple transactions together is being able to compare and contrast and gain the insights, right? So now this is the high level transactions that have been issued either by your UVM sequence or by a software. Now let's look at how do they get executed on a AXI channels, right? So now here I have AXI write. Uh, the channel level information. So what I'm going to do is let me filter from the transactions 9 to 12, right? Because that's what we want to focus on. So let me select the 9 and let me hold the shift key and select these first 4 transactions. Okay, so here we have how it's playing out on the um, AXI channels, right? So if we look at the dword aligned address 1000, right? So of course this is the starting of the burst, and let me little bit uh, zoom it further down. So yeah, so here we are issuing the write, and if we look at the write, and if we look at the strobe value, right? So the strobe value here is 3, right? And that 3 is essentially coming from these 2 bytes, right? So that I think is pretty clear. So so if we look at the next one, that is if we go to the transaction 10, right? Let me zoom this a little bit further. uh, I hope this is visible, or I can scroll also, not a problem. So this is now going to d word plus 1, and if you look at the data bus, right, the strobe value has gone to 6, right? Then there's going to this data byte utilization. Now if I look at the third one, right, so it's 1002, and if we look at the right data bus, it has gone to C. I think pretty much understandable. Now the interesting one would be when we go to the last one, wherein it is d word plus 3 and the length happens to be 2, right? So we have AW length of 2 bytes, and then so now here this AW length has become 2. That's the point I wanted you guys to notice. So in all these cases, it was able to do it in the single burst for the 2 bytes, whereas for the case where it is crossing the data bus width boundary, we are using 2 bursts, right? So in the first burst, we transfer the first byte, and that is utilizing a W strobe value of 8, right? So that's utilizing the byte lane 3, and but it is also using a second beat. Now in the second beat, what it is doing is it's utilizing the lower byte lane. So whenever the access has crossed the data bus width, what it has done is it has created multiple beats within the bursts, and it is able to do the writes, and it is utilizing the W strobes to manage the data byte lanes that have been selected for the access, right? So this is the case how it is behaving when it's not crossing the 4 KB address boundary. Now let's look at the next 4, right, wherein it will cross the address 4 KB address boundary, right? So let me select these 4. Let me just get rid of this guy. Sorry about that. Let me just select this guy. So yeah, we have these 4. Uh, so if we look at FFC, um, if you look at the FFC, it's again very similar to the way it was behaving for the first 4 bytes when we were trying to write. It's utilizing the W strobe value of 3. And for the next one where we are doing d word plus 1, it's utilizing a W strobe value of 6, wherein it is utilizing the byte lane 1 and 2. And for the d word plus 2, it's utilizing the byte lanes 2 and 3. But the interesting case is over here when we are doing to the d word plus 3. Here it's not only crossing the data bus width, but it's also crossing a 4 KB address boundary. And if you look at it over here, so what has happened is we are it is not issuing 2 beats, right? If you see here, it's issuing 2 bursts. So the first burst gets issued with the same address, and the when we do the write, it will utilize the um, lower byte lane, but it will start a new burst because it's crossing the 4 KB address boundary. And here it will be utilizing a strobe value of 1, wherein it's trying to utilize the lower byte lane for doing the write. So you can see now, let's just pick only the transactions 12 and 16 to sort of contrast and compare how they are different, right? So let me just select these two transactions. So here it was just crossing a data bus width boundary, and this guy was executed in the form of 2 beats. So you can note that the W last was false over here and W last is true over here. So it was executed in the form of 2 beats, and we got a single right response. Whereas this guy, we are crossing a 4 KB boundary, and the spec says that a burst cannot cross 4 KB boundary. So now what it is doing is it's just initiating one beat, and it's completing that and initiating a new burst, and then utilizing the write phase of the new burst for sending the second byte. And as you can see, there are two responses coming back from the slave. So I hope this helps you clarify how the AXI bus behaves when it crosses the data bus width boundary and as well as 4 KB boundary. If you have any questions, you can put it in the comments, and we will get back to you. Thank you.